Finishing up with elimination, we've looked at all the possible scenarios really in terms of trying to create opposites where we already have opposites, or we just need to multiply by a negative sign to create opposites, or multiplying one equation by a number to create opposites, or multiplying both equations to create opposites. So we've pretty much dealt with everything as far as creating opposite goes. So in this last worksheet, we kind of just throw a couple other things on you that we haven't run into before. The equations may or not be in standard form, and then also throw some fractions at you. But we're going to handle those very, the way we always handle them with algebra or in math. If it's not in the order that we like, we just add the opposite to move things to the other side to get the form that we want. So we're going to use adding the opposite to each side of the equation to move things around and to get them in standard form. And we know how to deal with fractions. We simply multiply by the denominator of the fraction using the same property we used in steps 2 and 3 here, where if we multiply an equation by the same number, we can do that all day long as we do that to every term in the equation. So the most difficult part of these problems is really going to be just getting things in the form that we need so that then we can look at creating opposites. So getting them in standard form, taking care of fractions, and then looking to create opposites. Okay, so that kind of sums up what we're going to be doing on this worksheet. So let's jump right in. So as we look at our first step is we want to make sure our equations are in standard form. Well, as we look at this first equation, it's not in standard form. The second equation is also not in standard form. And you remember standard form is simply you have the x term first, you have the y term second, and then on the other side of the equal sign you have your constant. So when you're looking at doing that, you just want to move the fewest amount of terms as possible. So we already have in equation 1 here, we have the x and the y on this side already. The only thing we really want is this constant number to be on the other side. So we can do that or accomplish that by adding the opposite of that number to both sides of the equation. So we're going to do that, and we're going to rewrite the new equation down here. So we're still going to have negative 2x because we didn't move that, we didn't do anything with that. We're still going to have the negative 4y because we didn't move that. And then the 14 minus the 14 is 0, so it's no longer on this side. And then 14 plus 0 is 14. So we now have the first equation in standard form. In the second equation, again, we notice it's not in standard form. We do have the x and the y on the same side, which is what we want. The only thing we don't want is this 18. So we'll move that to the other side by adding its opposite to both sides. So again, lining up our equation then, we didn't do anything with the 3x, so it's still on this side. We didn't do anything with the y, so it's still on that side. And the 18 now is on the other side of the equal sign as a negative 18. So we now have our equations in standard form. We can now look for opposites. The x coefficients are not opposite, the y coefficients are not opposites. So can we multiply one equation by a number to create opposites? I cannot do that with the x's, I cannot do that with the y, so I'm going to have to multiply both equations by a different number in order to create opposites. So I'm going to go ahead, because the x's already had positive and negative signs with them, I'm just going to create opposites by multiplying by a number. So I'm going to multiply this first equation by the coefficient of the second one, which is a 3. So we're going to multiply this by a 3. And then I'm going to multiply the second equation by the coefficient of the first, which is a 2. And again, I don't need to worry about the negative sign because the x's are already opposite signs. We just need them to be opposite in value. So now I have to multiply each of these equations to create my new equation. So I'm going to have two new equations. I'm going to have to rewrite those. So the 3 times the 2 is negative 6x. The 3 times the negative 4 is negative 12y. Oh, that 2. And then the 3 times 14, that's 30 and 12, which is 42. And then multiplying the second equation, we have 2 times 3, which is 6x. They're my opposites. The 2 times the 3 is a positive 6y. and then 2 times negative 18 is negative 36. So I now have got my equations where they're opposites and in standard form. So really all we had to do is just get those in standard form, the only extra thing we had to do there. So now that we have opposite coefficients, we can add those together. So 6x and negative 6x is 0, so the x variable is eliminated. We have negative 12 and a positive 6, so that's negative 6y. And then I have 42 minus 36, which is a positive 6. I then multiply by the reciprocal of negative 6, or divide by negative 6. Okay, and so these negative 6 reduce here. This can get kind of out of room here, so I'm going to go over here, y. And then this 6 and this 6 are both divisible by 6, so that gives me 1 with a negative sign in the denominator. So a positive over a negative is a negative 1. So the y value of my solution is a negative 1. I now need to determine the x value. Now, I can go back, as always, to the original 2 equations if I'd like. I can go back to the 2 equations that are in standard form, or I could go back to the 2 equations, new equations that I have after I multiplied by those numbers. So any of those equations I can go back to and substitute this number for y in and determine the value of x. I'm going to go back to this equation right here, so this new equation here, and we're going to substitute in the y value of negative 1. So doing that, copying that equation, I have 3x plus 3 times the y value, which I now know is negative 1, equals negative 18. I then am going to solve this equation. So first I need to multiply those together. So I'm going to move over just a little bit so I don't run into that negative 1 down there. So I have 3x. 3 times negative 1 is negative 3 equals negative 18. I don't have any more like terms to take care of, so I'm going to move this 3 to the other side so I can get that x variable by itself. So 3x. 3 minus 3 is 0. And then negative 18 and 3 is negative 15. I then am going to divide by 3, which means I'm going to multiply by the reciprocal of 3, which is 1 over 3. The 3 is reduced to 1. 1 times x is x. And that 3 and 15 are both divisible by 3. So I have this negative 5 in my numerator over 1. So I have an x value of negative 5. So the solution to this system is the ordered pair negative 5, negative 1. On number 3 on our worksheet then, we have our next system. We want to look and see if our equations are in standard form. The first equation is not in standard form. I need the x term and the y term on the same side. So the easiest way to do that is to move this y over here, then I'll have the x and the y on the same side. So I'm going to add the y to both sides. And then I'm also going to switch those so that they're lined up here. So I'm going to put the x term first, so that's going to give me, I'm going to go up here. I think I'm going to need a little bit more room here on this one. So that's going to give me the 3/4 x is over here, and then I have the positive y, and then I have my equal sign, and then I have the 1, and then I have the y plus y, which is 0, so the y is no longer on that side, so I have this in standard form. The second equation is also not in standard form, and the easiest way to get this in standard form is to also move this y term over to the side with the x. So in order to do that, I need to add the opposite of that term to both sides of the equation. So rewriting this then, the x term, 8x, is on this side, so that's fine. I now have the 6y on that side as well, and I have my equal sign, and then I have the number 6. Okay. Now I have them in standard form, but I have this fraction, and I'd really like to not have to deal with that fraction through the entire process. So we're going to get rid of that fraction right now. And remember, to remove a fraction from an equation, you simply multiply by that denominator. But just like our properties in creating opposites, we have to make sure we do that to every term in the equation. So we need to make sure that we multiply that denominator by every term in the expression. So doing that, we're going to move this over here. The 4's in my denominator numerator are reduced, leaving me 3 and x. and then I have 4 times y, which is 4y, and then I have equal sign, and 4 times 1 is 4, and then I have this other equation, which I'm not changing right now, so we're just going to leave that as is. And so now I have my equations in standard form, and I also have the fractions taken care of. So now I have it looking nice and easier for me, at least in terms of visual. So now I can go to step 2. Can I create opposites by multiplying one equation by one number? So I cannot do that with my x terms, and I cannot do that with my y's, so I'm going to have to multiply both equations by different numbers. So we're going to eliminate the x's here, I guess. So in order to create opposites, I'm going to multiply the first equation by this coefficient of the second equation. So I'm going to multiply everything by an 8. Okay, so everything gets multiplied by an 8. And then I'm going to multiply the second equation by the coefficient of the first, which is a 3. But this 8 times 3 in the first is going to be positive. I need this one to be negative, so I'm going to multiply this here by a negative 3 then. So all of these are going to be multiplied by negative 3. So we're going to move these equations over here when we do this. So I have 8 times 3, which is my 24x. And then I have 8 times 4, which is 32y. And then 8 times 4, which is 32. And then my second equation, I'm going to do negative 3 times 8, which is negative 24x. So there are my opposites. Negative 3 times 6 is negative 18. And then 6 times negative 3 is negative 18 again. So now that I have created my opposites, I can go ahead and add these two equations together. Okay, and so I have 24, negative 24, which is 0. 32 minus 18 is 14y. And then 32 minus 18 is 14 again. So then we're going to multiply by the reciprocal, or we're going to divide by 14, which is multiplying by the reciprocal. So these 14s reduce, leaving me 1y, which is y. And these 14s reduce to 1, leaving me a value of 1. So the y value of my solution is the number 1. Now, to determine the x value, I can go back to any of the equations that I've used in my entire process of solving. So I can go back to the original 2. I can go back to the 2 after I put them in standard form. I can go back to the 2 after I eliminated or remove the refraction, or I could go back to the 2 that I got after I multiplied each of those numbers. It doesn't matter which one you use, you can go back to any of them and still determine the value of x. Well, I don't want to use the first 2 because I don't want to deal with that fraction. I don't want to use these 2 because I still have a fraction. Well, actually, I could, just that first one is one I wouldn't want to use. So actually, I think having talked about that or thought about all that, I think I'm going to go back to this equation here. It doesn't have any fractions, so let's go ahead and do that. So copying this equation, and then when I come to the letter y, I'm going to substitute in the value that I just determined here, which is a 1. So I have 8x then, and then I have 6, and then negative 6 times 1 is negative 6. So adding these like terms together, I get x is equal to 0. And I'm going to move up here. So I have 8x is equal to 0, and then I'm going to divide by 8, which means I'm going to multiply by the reciprocal of 8. So the 8's reduced to 1. 1 times x is x, and then 0 times anything is 0. So the x value is 0. So the solution to my system is the ordered pair 0, 1. Okay, seems like a lot of work, but really the first 2 steps are just getting things in order for us, getting them in standard form, getting rid of the fractions, and then we're just doing what we did on the last couple of worksheets, creating opposites by multiplying these equations by different values. Looking at number 5, again, following our steps, we look for the equations to be in standard form. As we look at the first equation, it's not in standard form. Oh, I'm sorry, it is in standard form. I have my x and the y on one side and the constants on the other. So there's nothing wrong with that one as far as standard form goes, so we're going to leave that one. Except that we're going to switch everything on the equal sign. So we're going to put this side of the equal sign first. So let's see, we're going to have 4/5 x, and then we got the positive y and our equal sign, and then we're going to have the -7/5. So all I did was switch the sides of the equal sign. The second equation is not in standard form, so we do want to do that. The only problem is this -4 is in the way. So we're going to move that to the other side by adding its opposite. So we're going to add that opposite to the other side. So that means this -x is still going to be here, so we're going to have that. Then we have this positive y, and then we have 4 plus 0 is 4. So now I have them in standard form, but I have fractions. So I'm going to get rid of those fractions, and again, to remove the fractions from an equation, we simply multiply by the denominator. Now these both have the same denominator, so we're going to multiply by 5. And again, whenever we decide to multiply an equation by a number, we can do that all day long as we do that to every term in the equation. So this equation then, if we do that, the 5 in the denominator is going to reduce with that 5 I'm multiplying by, which is just going to leave me 4x. I'm going to have 5 times y here, which is going to give me 5y. And then this 5 in the denominator is going to reduce with that 5, leaving me -7. The second equation doesn't need to be changed. We don't have any fractions, so we're going to leave that one as is. Okay, and so we'll just have this. Now, we look for opposites. We don't have opposites here in the x, we don't have opposites in the y. We look to multiply one equation by a number to create opposites. Well, we can do that here because all we have to do is multiply the second equation by a 4, and that's going to give me a -4x. So this one, all we have to do is multiply the second equation by a 4. And again, as long as I do that to every term in the equation, that's okay. So the first equation is not going to be changed. We're going to leave that one as is. So we're going to have 4x and 5y is equal to -7. And then multiplying 4 times -1 is -4x. There are my opposites. I really have a problem with some of these strokes on this pen. I think I need to change the tip in there. But anyways, that's my problem, not yours. 4 times 1y is 4y. Okay, and then 4 times 4 is 16. So I've created the opposites then by multiplying the one equation by opposite values. So I can go ahead and add these now. 4x and -4x is 0. 5y plus 4y is 9y. I have my equal sign, and then 17 minus 6 is 9. I can then multiply by the reciprocal of 9, which is dividing by 9. So those 9's reduce to 1, leaving me 1 times y, which is y. And these reduce to 1, leaving me 1 over 1, which is 1. So the y value of my solution is a 1. Now to determine the x value, again, I can go back to any of these equations that I've used all the way through here, whether the two originals or these two, it doesn't matter. I'm going to go back to, let's say, this equation right here and substitute in our y value. So that gives me -x plus my y value, which is a 1, is equal to 4. Now I want my x to be positive here, so I'm going to add x to the other side. Okay, and so x minus x is 0, leaving me a positive 1 on this side, and then I have 4 plus x. And then to solve for x, I just need to add the opposite of this 4 to both sides to get my x. So 1 minus 4 is a -3. I have my equal sign. 4 minus 4 is 0, and that leaves me x. So my x value is a -3. So the solution to my system here is the ordered pair -3, 1. With our next example, we always want to follow our steps. So are the equations in standard form? The first equation is in standard form, so I don't need to change that one. So I'm going to rewrite it down here because we are probably going to have to change, or we will have to take care of those fractions here in a minute. So I'll do this. As I look at the second equation, it's not in standard form, and to put it in standard form, I need this y over here with this x. So adding its opposite, moving it to the other side, is going to take care of that. So I'm going to rewrite it in the order that I want it. So over on this side of the equal sign, I have my 4x first, Then I'm going to have my negative 8y. And then I'm going to have my equal sign. And then this is 0, so I'm just going to have a 4 over here on this side. Now, in the first equation, I would like to get rid of those fractions so I don't have to deal with those for the rest of my problem. So the denominator is a 2. So I'm going to multiply every term in the expression, in the equation, by a 2 and create an equation without fractions. So the 2 in the denominator reduces with the 2 in that numerator of 1, leaving me negative 1x. So that's just negative 1x. The 2 in my denominator here and the 2 here reduce, leaving me a positive 1y. And then I have my equal sign, and then 2 times 1 is 2. And then the second equation we're not changing at all, so we're just going to copy that over here. So now I have my equations in standard form. I look for opposites. The x's are not opposite, the y coefficients are not opposites. So we then look, can I multiply one equation by a number to create opposites? And again, I can do that here because all I have to do is multiply this 1x by a 4 to give me negative 4, and then those x values are going to be opposites. I could also do the y here, multiply by 8, and then the 8 and negative 8 would be opposites. So I have options here. But I like to multiply by smaller numbers if I can, so I'm going to use the number 4. So I'm going to multiply this first equation by the number 4 in order to make those x coefficients opposite. So in doing that, I've got 4 times negative 1, which is negative 4x. I have 4 times 1y, which is positive 4y. And then I have 2 times 4, which is 8. The second equation is not being changed, so we're going to keep that. So 4x, there are my opposites. Then I have negative 8y. And then I have 4. So now that I have opposite coefficients for my x variables, I can go ahead and add these equations together to eliminate the one variable. So negative 4x and 4x is 0. Negative 8y and 4y is a negative 4y. And then 8 plus 4 is 12. I then want to divide by that 4, negative 4, so I'm going to multiply by the reciprocal. So that's going to be multiplying by negative 1 over 4. So the negative 4 is reduced to 1, leaving me 1 times y, which is y. 12 and 4 I can reduce, make that a 3, so I have a positive times this negative, so that's going to be a negative 3 over 1. So my y value for my solution is the negative 3. I now need to determine the x value, and again I can go back to either the original two equations or any of these other equations that I've used in the process of elimination to determine my x value. Again, I'm going to go to this equation just because I can work right below it. It's a little bit easier for me. So the 4x minus the 8 times the y value, which I now know is a negative 3, and that is equal to jumping ahead of myself there, that is equal to a 4. Multiplying first, so we're going to have negative 8 times negative 3, which is a positive 24. We then look for like terms to add on both sides, which is all done. So we want to isolate the term we're solving for, so we're going to subtract 24 from both sides. So that's going to leave me 4x. 24 minus 24 is 0. Negative 24 and 4 is a negative 20. We then are going to divide by 4, which means we're going to multiply by the reciprocal of 4. So the 4 is reduced to 1, leaving me 1 times x, which is x. The 4 and the 20 are both divisible by 4, and so I have negative 5 times 1, which is negative 5. So the x value of my solution is a negative 5. So the ordered pair negative 5, negative 3 is the solution to the system. One final example for elimination. Again, we want to follow our steps, so we look and do we have equations in standard form. The first equation is not in standard form, and what we need to do is to move this 4 to the other side, leaving me x and y on just this one side. So subtracting 4 from both sides and then writing it in order of standard form, I'm going to have the positive 2x first. I'm then going to have my positive 4y next. and then I'm going to have my equal sign, and then on the other side we're going to have negative 4. As I look at the second equation, it also is not in standard form, and this 6, move it to the other side, would get me the in standard form the quickest, so we're going to do that. So again, I want to write the x term first, so that's a 3x. And then I'm going to have my y term, which is negative 5y. Then I'm going to have my equal sign and negative 6. I don't have any fractions to deal with, so I can go ahead and look for opposites. The x coefficients are not opposites. The y coefficients are not opposites. So can I multiply one equation by a number to create opposites? I cannot do that with the x's, and I cannot do that with the y's, so I'm going to have to multiply both equations by different numbers in order to create opposites. Now, the y values have opposite signs, so I'm going to choose to multiply these equations by these coefficients in order to create opposites. If you just want to work with smaller numbers, you can use the 2 and 3 of the x's, but it doesn't matter. I don't like multiplying by negatives because sometimes I get lost, so if they're already positive and negative, I just prefer to go that way. So I'm going to need to multiply this first equation by the second equation's coefficient of 5. So I'm going to multiply every term in this equation by a 5. And I need to multiply the second equation by the coefficient of the first. So that's a 4, so I'm going to multiply everything in the second equation by a 4. If I can write a 4, there we go. Seems like if I go kind of slow, that works the best. I'm going to slow down a little bit. Okay, so multiplying this first equation by that 5, then I have the 2 times the 5, which is a 10x. I have 5 times 4, which is 20y then. And then I have 5 times negative 4, which is negative 20. My second equation, I have 3 times 4, which is 12x. I have 4 times negative 5, which is negative 20y. They're my opposites. And then negative 6 times 4 is negative 24. So I've created the opposite coefficients, so I can go ahead and add these equations together. Let's see, 10 and 12 is 22x. 20 minus 20 is 0, so I don't have that. A y is eliminated. Equals, and then negative 20 and negative 24 is negative 44. So then I want to divide by 22, which means I multiply by the reciprocal of 22. So it's simply 1 over 22. So the 22 is reduced to 1s, leaving me 1 times x, which is x. The 22 reduces with this 44 2, so I have a negative 2 over 1, which is negative 2. So the x value of my solution is a negative 2. To determine the y value, I can go back to either the original equations or any of these other equations that I've created while setting up my elimination process. Again, I'm just going to go with this equation here because I can work right below it and just kind of copy. It's a little bit easier than working with the other one. So we're going to take my first equation, and when I come to the letter x, I'm going to substitute in the value, which I now know is a negative 2. Negative 5y is negative 6. And then I'm going to multiply this, so this is negative 6 minus 5y is equal to negative 6. I'm going to look to add like terms, which I don't have any, so we can go ahead and add the opposite of this 6 to get the term I'm solving for isolated. So that's going to be negative 5y is equal to 6 minus 6, which is 0. Then multiplying by the reciprocal of negative 5, that's 1 over negative 5, or negative 1/5, however you'd like to look at that. So the negative 5 is reduced to 1, leaving me y. It's getting kind of squished at the bottom here, but fortunately I'm almost done. And 0 times a fraction, or 0 times anything, is 0. So the y value of my ordered pair is 0. So the solution to this ordered pair is a negative 2, 0. So that's solving a system by elimination. If you just remember those 4 steps and then create those opposite coefficients, everything will work out great for you.